Next topic is inequalities involving modulus. Similarly, as we solve equations involving modulus using three methods, in the same way, inequalities are also solved using three methods. One is graphical, second is using definition, and third is by squaring. Okay, so let us see the question that we have to solve the inequality mod of x minus 2 is greater than equal to 2x plus 1. If you have to solve this using graph, so let us quickly sketch the graph of both these functions. One is mod of x minus 2 and another one is 2x plus 1. So let us say these are our coordinate x's, and if I have to draw x minus 2 modulus, we have done this earlier. Let us say this point is 2, so this is a v-shaped curve whose point of intersection with the x-axis or the corner point is 2. Okay, so this is your blue graph, which is of x minus 2. Let me name this. Right hand side will be of x minus 2 and left hand side will be of minus of x minus 2. Okay, and on RHS we have to draw 2x plus 1. You will look here that slope of this function is 2 and slope of this function is 1. So I need to increase the slope of this straight line. So this will be like 2x plus 1 and the y-intercept is plus 1. So I'm sorry, let us say something like this. Okay, and let us extend this to the negative y-axis. So I think this is fair enough. So this graph is of 2x plus 1. Fine. Now as you can see that we have to look for this blue graph, which is of mod of x minus 2, that should be greater than 2x plus 1, right? So this point of intersection is, you can say, the critical point. This will give you the solution, right? That means we have to solve this graph, which is minus x minus 2 and 2x plus 1. So let us quickly solve. 2x plus 1 is equal to minus of x plus 2. This is 3x. This is 3x is equal to 1. So x is 1 over 3. Okay, so this point is 1 by 3. Now if you look closely here, that after this x equal to 1 by 3, this green curve means 2x plus 1 lies above the blue curve, right? So after x equal to 1 by 3, for x greater than equal to 1 by 3, mod of x minus 2 is always less than 2x plus 1, right? So solution will be opposite side, means for all the values of x which are less than 1 by 3, blue curve means the mod of x minus 2 will always be greater than this green curve, which is 2x plus 1. Okay, so from the graph I can write down the solution as for all the values of x which are less than equal to 1 by 3. Okay, if you solve this x minus 2 greater than equal to 2x by 3 by squaring the method, using the squaring method, which we will do later on, okay, you will get 2 points of intersection, but in that case this x minus 2 will be x minus 2 whole square, and it will give you another point of intersection which will be here. Okay, but as you can see from the graph that this mod of x minus 2 can never lie below the x-axis, it will always be above the x-axis. So there is only a single point of intersection, which is this x equal to 1 by 3. Okay, so my solution is x less than equal to 1 by 3. Let us solve using second method, which is your basic definition of modulus, which is that mod of x minus 2, it is greater than equal to, we have to find out for 2x plus 1. Okay, so this will be x minus 2 is greater than equal to 2x plus 1, using the distance concept, that modulus of anything is just a distance. So if I say that this is greater than 2x plus 1, That means if this is my number line and this is your 2, means here you are, this is your origin or the reference point. So it is saying that distance is greater than 2x plus 1. Greater than 2x plus 1 means either my distance is greater than 2x plus 1, means equation number 1, inequality number 1, or that the distance is less than equal to minus of 2x plus 1. Right, just like we did x minus 2 is greater than equal to 5. That means my distance is either I'm moving towards either I'm moving in the right direction or I'm moving in the left direction. For right direction, sign is positive, and if I'm moving towards left, sign is negative. Okay, so this inequality says that my distance is greater than 2x plus 1 means I'm moving in plus direction towards right. Okay, and this inequality indicates that I'm moving in the opposite direction. So here you will get x as less than x is less than minus 1, I think. This is, wait a minute, this is x minus 2 mod greater than equal to 2x plus 1. Okay, so x minus 2 greater than 2x plus 1, or x minus 2 is less than equal to minus of 2x plus 1. So if I solve this inequality, this is x minus 2 less than equal to minus 2x minus 1. So this is 3x less than equal to minus 2 plus 1 is 1. So this is x less than equal to 1 by 3. And here I will get x which is less than minus 3. Okay, x less than equal to minus 3. So if we have to look union, means either x is less than equal to minus 3. Suppose this is minus 3 and this is 1 by 3. So first inequality says that it is less than equal to minus 3, and second says it is less than equal to 1 by 3, and I have to take the union of this, means either this or this. That means my final solution will be x less than equal to 1 by 3. Okay, had it been and, we have to look for the and, then we should take the intersection, but here it is not and, it is or. Okay, so you can think logically that if x is less than equal to minus 3 or x is less than 1 by 3, so basically x is in the solution, all these portions, all these values will also come. Okay, because one condition is satisfied. Okay, so this is x less than equal to 1 by 3. Now third method, if you use, means squaring the method, squaring the inequality, means this is 2x plus 1, and if you square these, this approach is wrong. We cannot square on both the sides until and unless we know that your RHS is positive or negative. Okay, for example, if I say that mod x is greater than equal to minus 5, if I square this, you will get mod x is greater than, mod x square is greater than equal to 25. Okay, if it is greater than equal to 25, but if it is less than minus 5, mod x square again will be less than equal to 25. Okay, that means in the first condition it is giving greater than 25, in the second condition it is giving less than 25, until and unless we do not know the sign of this, means we have to interchange the sign in this case. Okay, until and unless we do not know that both the sides are positive or negative, we cannot square, right? Please remember this fact. Okay, so here we cannot use the squaring method. Let us do second question. Solve this inequality. Mod of x plus 1 is less than mod of x minus 2. Graphically you can solve this. Let us sketch the graph of these two quickly. This graph, let us draw this by using green color, x minus 1. Let us say this point is minus 1. So V-shaped curve like this. And then x minus 2 is our old graph. This is again a V-shaped curve and slope will be same. Okay, means plus 1. Okay, let us name these two graphs. This is the positive side of x minus 2, so this is x minus 2. This curve is minus of x minus 2. This green curve is x plus 1, and this portion of the curve is minus of x plus 1. Okay, so we have to look for all the values of x, for a range of values of x for which this green curve is below the blue curve. Okay, green curve is below the blue curve. So from the graph, we have to find out this point of intersection. Okay, this point of intersection, as you can see, that green curve lies below the blue curve for the values which are less than this critical value c. Okay, less than this critical value c, green curve lies below the blue curve. Okay, otherwise green curve is above the blue curve always. Okay, so that means you have to find out this point of intersection by solving these two equations. One is x plus 1 and second is minus of x minus 2, means minus x plus 2. So 2x is equal to 1, x is equal to 1 over 2. So this value is 1 over 2. Okay. So from the graph, the solution is coming out to be that x is less than equal to 1 over 2. Okay. Similarly, you can solve using the squaring method. Here we can use the squaring method because we know that both the sides of inequalities are positive. Okay, output for this inequality will be positive, this is positive, so we can square without changing the sign. Okay, the problem comes when we do not know whether the one side is positive or negative, because in that case, sign of the inequality has to be adjusted. Okay, so solution is this. If I have to use the squaring method, we can use the square method. Here we have x plus 1 square less than x minus 2 square. That means x square plus 1 plus 2x is less than x square plus 4 minus 4x. Okay, x square gets cancelled with x square. I get 6x is less than 3, so x is less than half. Here is a correction, small correction, that this half is not included because there is no equality involved in this. So this is just x less than half. Okay, fine. So solution is coming out to be x less than half. Next question is that we have to express the inequality x lying between minus 2 to 6 in the form of modulus of x minus a less than b, where a and b are some values which are needed to be found. So how to approach this question? Let us see. We can apply the basic definition of modulus, that this is written mod of x minus a less than b. That means, according to the definition, that my distance is less than b. Okay, so the maximum value could be plus b and minimum value could be minus b, because I have to remain within these limits. Okay, this is the limit where I can move. My distance should be less than b. It should not be beyond plus b, or it should not be beyond minus b. Why minus b? Because they are again two direction of movement. If I'm moving towards right, so I need to, means if this is my starting point A, so I should move till plus b, or I can move towards left till minus b. If I'm moving towards towards left, the point should be minus b and it should be less than minus b. We cannot say less than minus b because distance should be less than b, but in terms of sign, it should be this a is of course greater than minus b because it is lying in the right side of minus b. So solution is that x minus a should be less than b, or x minus a should be greater than minus b. Okay, because this x minus a, if I'm moving in the left direction, the values which are lying towards the right are greater than this value. Okay, so x is less than a plus b, or x is greater than a minus b. Okay, now the given inequality is that x is less than 6 and it is greater than minus 2. If I have to combine these two inequalities, I can write that my x is less than a plus b and it is greater than a minus b, right? So I can compare these two equations, right? I can compare these two equations. I can write that a minus b value has to be minus 2 and a plus b value has to be 6. We can solve this. 2a is equal to 4, that means a is equal to 2 and b is equal to 4. Okay, so my inequality is, I can write this inequality in terms of a and b or in modulus term like this, that x minus 2 modulus is less than 4. Okay, we can visualize this by again applying the concept of distance, that if my initial position is 2, suppose this is our number line, my initial position is, let us say, 2. So it says that my movement should be less than 4, my distance should be less than 4. So if I am moving in the right direction towards right, the distance should be less than 4. So the maximum point I can arrive is 0.6. Okay, because this distance can be maximum be 4. Okay, but if I'm moving in the left direction, so 4 units towards left, okay, I will arrive at, this is minus 1, this is 1, sorry, this is 0, this is minus 1 and this is minus 2. So this is minus 2. Okay, so 4 distance in the right is 6, 4 distance in the left is minus 2. Hence the inequality, as you can see in the question, is that my x is lying between minus 2 and 6. Okay, so it basically is that my initial position is 2. If I have to move a distance such that in the right direction, such that the maximum value should be 4. Okay, so the rightmost point will be 6 and the leftmost point will be minus 4. Okay. Again, on the same line, the question could be asked, means the language can be changed, that we have to find out the greatest and least value of x satisfying the inequality mod of 2x minus 1 is less than 5. Okay, again on the same line, we can apply the basic definition that 2x minus 1 should be less than 5, or 2x minus 1 is greater than equal to minus 5. That means 2x is less than equal to 6, or x is less than equal to 3, or 2x is less than equal to minus 4, or x is greater than equal to minus 2. Okay, so combining these two inequalities, I can write that x is less than equal to 3 and it is greater than equal to minus 2. So it is asking for the greatest value. Greatest value is 3 and least value is minus 2. This is my least value and 3 is your greatest value. Okay, easy question. Next is, we have to solve the equation, this cubic equation, and we have to show all your working. This is from the past papers. Okay, so solution. Please do not square this because you will get in trouble, because this is a cubic equation and in that case this will be x raised to power 6. Okay, so let us replace this x cube by some another variable, let us say y. So let y is equal to x cube. This implies our equation is now y minus 14 modulus is equal to 13. Right, now this is a cup of cake. which is y minus 14 is plus 13, or y minus 14 is equal to minus 13, right? That means y is equal to 27 or y is equal to just plus 1. That means x cube, replacing the value of y with x cube is 27 or x cube is 1. So from this we get value of x is 3 or value of x is 1. Okay, this is your answer. You can verify this, that x cube means 27 minus 14 is 13, and similarly 1 cube means 1 minus 14 is minus 13 ka modulus is also 13. Okay, thank you. So here we have finished with our first unit, which is algebra. We have already done chapter number 1, which was polynomials, and then we have covered the modulus. Okay, we will start with next unit, which is logarithm and exponentials, in the next videos. Till then, take care. Bye bye. Thank you. See you next time.